following video is going to investigate how to use spreadsheet software such as Microsoft Excel to determine the compound interest savings for three different accounts. The accounts of Tim and Jim and Ben. Now each of them invests a particular amount of money. You recall the initial investment is what's known as the principal. So Tim invests $2,000 and Jim invests $1,875 and Ben invests $1,800. They also invest them at different interest rates and for different time periods. So their interest rates are, as a decimal, 0.045 or 4.5% for Tim, 0.05 or 4.8, so 4.8% for Jim, and 0.05 or 5% for Ben. And the number of payments, or the number of times its interest is paid per year. So if we look at the number of interest payments per year, we know that Tim's is monthly, so that's 12 times a year. Jim's is semi-annually, so that's twice a year. And Ben's is annually, so that's once a year. So you can see we got the basics information for each of these individuals set up. Now in a spreadsheet software, things can be easily copied and pasted into a word processor. So you may want to sort of reorganize things so that they look a little better. One thing you can do is you can select all of your data so far. If you go to the top and you can see those two arrows between A and B, if I double click there, what it does is it automatically sizes the cells so that each of them sort of fits their content. Then if I select these three values, because they're unique values, I can click on this paint bucket and just set the background color for those. And you can set them as different ones or you can make them all the same. It's just showing that something unique is there. The other thing is these three numbers here represent dollar amounts. So I may want them to show up in my spreadsheet as dollars. So you can see at the top here under the number formatting, I can click on dollars for English Canada and it just brings them up as a dollars or cents value. So we know what information we're starting off with. Then what we need to do is we need to figure out, after a period of time, what is the future value of the account. And then I'm just going to copy and paste that, Control C and Control V in each of the cells. And again, I can make it automatically fit my largest cell by going to the top and double clicking when I see the double arrow. So we know we have 0, 1, 2, 3, and 4 years are the amount of time we're looking at. You may also recall that you were introduced in the lesson to an equation to calculate the future value. So that equation looks like this. The future value is equal to the present value by 1 plus r over n, where r is the rate and n is the number of payments per year, to the power of nt, where n is the number of payments per year and t is the time that passes in years. So that equation looks like this. What makes a spreadsheet useful is we can, instead of calculating that each and every time, we can enter the equation into our spreadsheet and it will do the calculations for us. So what we want to do for this first one is I'm going to press the equal sign. As soon as you press the equal sign in the spreadsheet, it tells you want to do a calculation. So we're trying to find the future values. The first thing we need is the principal. So we know that the principal for Tim is in cell B2. So what I'm going to do is going to put a dollar sign and a B and a dollar sign in 2. The reason for the dollar signs is that makes sure that no matter where I copy and paste or move things around, it's always going to look back at B and 2. And then I'm going to multiply that by 1 plus my rate. So my rate is 0.045, but that is in cell B3. So I'm going to press $sign in the letter B and $sign in the number 3. Again, that means it's always going to look at B3. And then divided by N, the number of payments per year. Well, my number of interest payments per year is in B4. So again, $B, $4. And close that bracket. To the power of NT. So to get to the power of, we use Shift and 6, and you get that little notation for to the power of. So the power of NT. So remember, N is in B4. So I'm going to go $B again and $4 by T. Now T in this case, I'm not going to use the $. And the reason I'm not going to use the $, is because I don't always want to look at T equals 0. My T is going to change from 0 to 1 to 2 to 3 to 4. So I'm going to multiply it by the cell A7. Because that is where my 0 is. And when I press enter, it gives me $2,000, which makes sense because that was my initial deposit. But what I can then do is once I have my equation entered, I can select the cells that I want and click up here on the top. You can see there's a fill. So I want to fill down using that system. And you see what it automatically does is it fills in the numbers or the calculations for each one. Now these are dollars and cents, so I'm going to copy those cells or select those cells and just change my value in the formatting to dollars. So you can see after 4 years, Tim will have $2,393.63. So if you want to do the same thing for Jim, we can go equals again, and it's going to be equals $C, because we're in the third C column now, $2, because the principal is not going to change. Multiplied by, and then open our bracket, 1 plus our interest rate, so $C, $3, divided by our number of payments, $C, $4, close our brackets, to the power of, and then open a bracket, and our time, our number of years, and our number of payments. So our number of payments is $C, $4 again, multiplied by, again, our first year is in A7. And when I press enter, it gives me $1,875, because that's how much I started off with. Then if I click fill down, you can see it automatically performs the calculations for me. And again, I can select these numbers here and change the formatting so that they are in dollars and cents. Now another way I could do this is I can copy this top cell to figure out Bend and go over and just paste that information in Bend. Now you can see it gives a whole bunch of number signs because it's really not sure what we're calculating. So if I go back up to my formula bar at the top here, up here, for Bend's information is not in C, it's in D. So I have to change this to a D, so D2, and change this to a D, so D3, change this to a D, so D4, change this to a D, so D5, or D4 again, and then finally change this back to an A because my number of years is in A7. When I do that, I get $1,800 at the start. And you can see it automatically copied the formatting because I already had it in dollars and cents. And if I fill down, I get the calculations for each one. So the question asked us, who had the most money saved after 4 years? So the person who had the most money saved after 4 years was Tim. He had $2,393, whereas Jim had $2,266.74, and Ben had $2,781. Now the nice thing that happens though is if you use the fill feature, it fills down the whole column even for numbers you didn't calculate. So suppose they decided not to go on their trip, but decided to save their money for some more time. So if we look at 5 years, or 6 years, or 7 years, or 8 years, you can see that the values are automatically filled in. So what happens if they decide to save their money for 20 years? Or 30 years? Right? And you can see as they're saving it, somewhere along the lines, Tim's money actually gets smaller in value compared to Jim's and Ben's money. His savings get smaller. That's somewhere between the 20 and 30 year period. But when you fill it in with the spreadsheet software, what you do is you get the ability to keep predicting future values without setting anything up. The other thing we can do pretty easily once we have our spreadsheet set up properly is, say Jim instead decided to invest $1,890, so $1,890. It automatically updates our calculation. Or if Ben invested $1,900, it automatically updates our calculations. So you can change the values pretty easily and compare different things once you set up a spreadsheet properly. Then if you save the spreadsheet, it can be used again and again for this type of calculation.